Dear students, welcome to this video. In this video, we are going to discuss about a chapter from class 10 science. The name of the chapter is acids, bases and salts, and this is the part 2 video. Dear students, in this chapter, we are going to discuss about the dilution of the acids and bases, pH scale, the importance of pH value in our daily life, and the manufacturing of the different salts and their uses in our daily life. So these are all the important points that we are going to discuss in this video. Dear students, in this slide we are going to discuss about dilution of acids or bases. Before going to the discussion, let's give a small example to you. Let's imagine your mother has given you a glass of buttermilk. You begin to taste the buttermilk. You feel the buttermilk is very salty. Now, how will you make it better to drink? No doubt, you are going to add water to the buttermilk. You will reduce the salty nature and you will enjoy the buttermilk. In the same way, now let's start our discussion. What is meant by dilution of acids or bases? The answer is decreasing the concentration of H plus ions or OH minus ions in a given acid or a base by using water is called dilution of acids or bases. Dear students, in this process, there is a very important precaution for you. What is the precaution? While diluting an acid or a base, it is better to add acid or base into the water drop by drop along with the wall of the test tube, followed by stirring. There is an important caution for you. Here, water should not be added to acid or base. Once again I am repeating, water should not be added to acid or base. Why? As it is highly exothermic reaction. We know that exothermic means liberation of the heat energy. So during this process, what happens? More heat energy is liberated. It may cause us the splash of the test tube and may cause the damage. That's why water should not be added to acid or base at the time of dilution. Dear students, in this slide we are going to discuss about the meaning of the pH scale. So before going to the discussion, I will ask two easy questions to you. Dear students, how do you measure the length of your textbook? The answer is simple, by using the scale. The next question is, how do you measure the density of milk? The answer is lactometer. The next question is, how do you measure the weight of your textbook? By using the scale. That means using the balance, we can measure the weight of the textbook. In the same way, students, how can we measure the strength of an acid or a base? That means by using the pH scale, we can measure the strength of an acid. Dear students, let's see the image of the pH scale. So the pH scale ranges from values from left to right, 0 to 14. You can notice the values ranges from 0 to 14. The middle point is the 7, which is called as a neutral point. A neutral point. Dear students, let's see some important characters of the pH scale. Point number 1, the values in pH scale ranges from 0 to 14. The second point is, if pH value is 0 to 6.9, the solution is acidic in nature. The third point is, as the pH value decreases, the acidic nature increases. Once again I am repeating, if the pH value decreases, acidic nature increases. The next point is, pH value of a neutral solution, that means a pure water, that is 7. Very important. The pH value of pure water is 7. The next point is, if pH value is 7.1 to 14, it is basic in nature. As pH value increases, basic nature also increases. Dear students, take care of the image of the pH scale and also the colors. In the left side, we can see the color goes on to the red. If more acidic, the pH scale shows the red color. If it's basic, the color may be the dark blue to the pink color. Sorry, purple color, not the pink color, it is the purple color. Dear students, in our daily life we are using so many things, so may be the fluids, so many solutions. We must aware of the pH values of those solutions for our better life leading. So the importance of pH value in our daily life, point number 1 is all physiological activities of plants and animals are pH sensitive. That means in a good pH range only the animal body and plant body, they work better. I give a small example for you. In human beings, the pH range is between 7 to 7.8. So in this pH in this range, our body works better. If the pH value changes beyond the 7.8, it may cause us some other health issues. The next point is, in agriculture, we must know the pH value of the soil, because by knowing the pH value of the soil, we can select the suitable fertilizers to get the better yield. The third point is, in human digestion, the pH value is very important, because the stomach produces the hydrochloric acid, which is a very strong acid. So we must know that we have to maintain a good pH value of the acid for our good digestion. The next point is to prevent the tooth decay. Sometimes what happens in our mouth, the pH of the mouth solution may reduce us to below the 5.5. So this causes the more acidic nature in the mouth, which causes the tooth decay. And to prevent the tooth decay, we have to select the right toothpaste, which can prevent the tooth decay. The next point is, some insects and some plants shows the self-defense by using by injecting some acids. Example, the ant, the wasp, and the honeybee. By their inject, they inject its formic acid or methanoic acid, which causes the irritation of the skin. That means we must know the pH value of those bites to get the good treatment. Dear students, in this slide we are going to discuss about CHLOR-ALKALI method. The question is, what is CHLOR-ALKALI method? It is a method in which production of sodium hydroxide, chlorine and hydrogen by passing current through the brine solution, that is sodium chloride solution. When current is passed at cathode, what happens? The hydrogen gas is liberated at cathode. Cathode means negative electrode. In the same way, at anode, what happens? At the positive electrode, what happens? There is liberation of the chlorine gas. The sodium hydride solution will remains in the turf. Very important, the uses of the hydrogen gas. So hydrogen gas is used as a fuel. It's also used in the manufacture of ammonia and the margarine. Margarine means artificial butter. At the same time, the uses of the chlorine. So as we know that chlorine is liberated at the anode, the chlorine gas is used as a best disinfectant. That means at the time of treating the water, we are using the chlorine gas. Also in the manufacturing of the PVC pipes. At the same time, the NaOH solution remains in the turf, which can be used as the degreasing metals. That means to remove the oils and the grease. In the manufacturing of the soaps, detergents and in paper making we are using the sodium hydroxide solution. So this is very important, children. Please take care of chlor-alkali method. Dear students, as we told earlier, in this video we are going to discuss about some important salts. That means the manufacturing of different salts and their uses. So the first salt is, that is the bleaching powder. So how can we prepare the bleaching powder? So the bleaching powder is prepared by action of chlorine gas on dry slaked lime. Here dry slaked lime means calcium hydroxide. When chlorine gas is passed through the calcium hydroxide, you will get the calcium oxychloride, that is the bleaching powder, plus water molecule. Now let's discuss about the uses of the bleaching powder. Point number one, it is used as a bleaching agent. That means it is used as in the bleaching the cotton and linen textiles. Also, the bleaching powder, it is used in the paper industry to remove the unwanted colors. Also, to bleach the washed clothes. Dear students, bleaching powder also used as a strong oxidizing agent during the different chemical reactions. Also, the bleaching powder is a best disinfecting agent which can kills the germs in the water at the time of the treatment of water. Dear students, the next slide is baking soda. The chemical name of baking soda is sodium hydrogen carbonate, that is NaHCO3. How can we prepare the baking soda? So baking soda can be prepared by heating the mixture of sodium chloride, water, carbon dioxide and ammonia to get the ammonium chloride and the sodium bicarbonate. Next, baking powder. Is there any difference between baking soda and the baking powder? Definitely, students. Baking powder, it is a mixture of baking soda and an edible acid like the tartaric acid. Dear students, when baking powder is added to the food items and heated, it liberates the carbon dioxide gas. Dear students, this carbon dioxide gas makes the food item porous and spongy, and it also makes the tasteful of the pakoras and idlis, dosa, like that. Now let's come to the uses of the baking soda. So point number one, for making baking powder. Baking powder makes the bread and cake spongy and crispy. The second point is, it is used as an antacid. Dear students, antacid means to get relief from acidity in the stomach. The third use of the baking soda, it is used in the soda acid fire extinguishers. That means at the time of any fire accidents, by using the fire extinguishers, we can control or we can extinguish the fire. So at that situation, we are going to use the baking soda. Dear students, the next salt is washing soda. Its chemical name is sodium carbonate decahydrate, that is Na2CO3 10H2O. How do you prepare the washing soda? The answer is, when sodium bicarbonate is heated, sodium carbonate is produced. On crystallization, washing soda is produced. The chemical reaction is 2NaHCO3 on heating gives the sodium carbonate, water and carbon dioxide. Again, this sodium carbonate is crystallized by using the water. Finally, we get the Na2CO3 plus H2O. So now let's come to the uses of the washing soda. Number one is, it is used in the soap, glass and paper industry, as a cleaning agent in domestic purpose for washing the clothes. Third point is to remove the permanent hardness of water, and also in making sodium compounds like borax. So these are the important uses of the washing soda. Dear students, what is meant by water of crystallization? The answer is, it is the fixed number of water molecules present in one formula unit of a salt. Example, copper sulfate 5H2O. Here CuSO4, it is a one formula unit of a salt which contains the 5 water molecules. In the same way, sodium carbonate, it is one formula unit of a salt which contains the 10 water molecules. Like that, calcium sulfate contains the 2 water molecules which is called as the gypsum. At the same time, the calcium sulfate which contains the half water molecule, it is called as the plaster of Paris. So these are all the some examples for the water of crystallization. Once I am repeating, CuSO4 5H2O, Na2CO3 10H2O, CaSO4 2H2O, and CaSO4 of H2O. Dear students, the last salt of this chapter is, that is, plaster of Paris. How do you prepare the plaster of Paris? That means when gypsum is heated at 373 Kelvin, that means 100 degrees centigrade, the gypsum loses the water molecule and produces the plaster of Paris. The chemical reaction is CaSO4 2H2O on heating produces CaSO4 of H2O, that is hemihydrate of water molecule. So what are the uses of the plaster of Paris? It is simply called as a POP. POP nothing but plaster of Paris. The first use of the POP is, it is used in making the toys for showcases. It is used for the decoration. It is also used in treatment of the bone fracture. Also, it is used in making the artificial bones and teeth. Dear students, so these are all the important uses of the plaster of Paris. So total students, in this chapter, in this video, we have discussed the so many salts and with their uses. Thank you for watching this video.